and just doing that other purpose, other things, the sharing the screen. Okay, I hope that you have already got the software, and I give you the video lecture in the YouTube, so I check that whether my students watch and how much time they watch. But I'm very sorry to share that information that any student hardly watch, and because I got the information from the YouTube uh, app. So it's sad, but still, from my side in the online, this pandemic situation, whatever I can uh, do from my side, I'm doing. I'm giving my 100%, but still, I expect from all of you that please try to cooperate with your teachers. Your not only me, your other teachers also, so that they also get the enthusiasm, because it's a give and take purpose. So whoever the students are present, please give your role in the chat box, and next we will. Okay, I think that it's almost 12. Uh, if any students wanted to join, he might join, but he missed last time. I just read, please join. Okay, my student, if you remember that we studied half-wave rectifier and full-wave rectifier, and we discussed that the half-wave rectifier is basically in the AC, definitely in the AC. What does rectifier means? The rectifier is basically the circuit where the input is AC signal, and in the output we get DC signal. Okay, so to convert from AC to DC, basically we use rectifier circuit. And in the rectifier circuit, it might be two types. One is half-wave rectifier, another one is full-wave rectifier. Okay, so half-wave rectifier, we can understand from the name also that half-wave means uh, in the AC circuit, or in the AC signal, we know that there are two types of cycle. One is positive cycle, another one is negative cycle. So in the half-wave rectifier, we get the first positive cycle in the output, but we do not get the negative cycle in the output. So that's why it is named as half wave. Okay, and the output is something like that. You see that? This is the output. Output is something like that, the input, output. But in the negative cycle, we do not get the output. You see that in the negative cycle, we get the output 0. So this is the half-wave rectifier circuit, where a resistance, a diode, and the voltage source is required. What about full wave rectifier? I'm just telling you, just for reminding you how the wave shapes will look like, just to give you remind the previous study. The full wave, you can see from here on also, my student, the full wave, you can understand from the name also. The full wave means that in the AC circuit, or sorry, not the circuit, the AC signal. In the AC signal, both the positive and negative cycle we get in the output as DC. Okay, so that's why it is the full wave rectifier. This circuit rectifies both the cycle of AC signal or AC voltage signal. So that's why it is full wave rectifier. So the output will be looks like this. No? The output will be looks like this. This is the output signal. You see that this is for positive cycle, this is for negative cycle, this is for positive cycle, this is for negative cycle. But in the half-wave rectifier, this will be for positive cycle, the negative cycle, there will be no voltage. Then it will be the positive cycle. So something like that. So today we will see this output graph in the simulation software, because we could not apply in the hardware, but both are same. Okay, we at least understand that how they works and what are the equipments basically needed for that. So my student, I'm going to the software. We all know that we're using Proteus software. We all are using Proteus software, and if you have the Proteus software, you please practice in home. So before doing that, let me tell you that at first of all we will do the half wave, then we'll do the full wave. Finally, today we'll also see the Zener operation. So this class might last longer. So please, I request you because in the last class I missed. So I wanted to show you these three things together, and we are also recording the video. Isn't is it? I'm recording. Yeah, I'm recording.
It's
Okay.
recorded, sir.
Yes, I'm recording. I'm just cross-checking the information one more time because it's very important. I'm also recording this video, so if you face any difficulty, you can see the video later because I will upload those two videos just after the class, after finishing my class. Okay, first of all, we will go for the halfway rectifier circuit. So what are needed things? My students, if you don't create any noise, I might unmute you. So at that time, it can be the interaction. Okay, I will ask question, you will give the answer. So it can be interaction. If you don't create any noise, I'm unmuting. Okay, first of all, we need to go to the component mode. The first, the top, the left side, you see the second symbol is the component mode. In the component mode, after clicking that, you go to the P. P means the peak device. P means the peak device. Okay, it's creating noise. Creating noise. If you, I ask question, you just unmute yourself and then answer me. So in the keywords, you search for that. So today, yesterday we required DC voltage. Today we'll require for half wave the AC voltage. So we'll write V sign, a VI sign. V sign. V sign means the general sign voltage source. Okay, the AC voltage source. Double click, it will be added. Next, we will require a diode. Okay, just we will write a diode or write generic diode because generic diode will help us. Yesterday we show you 1N4007. That was the most popular type of diode. We today we show generic diode. Let me write generic diode. Diode. Yes, we got the probably this the generic diode. Okay, double click that diode, it will be added diode. Next, we will add resistance. So write RES. Right, RES. Go to the lower value. Okay, we're not finding out. Okay, go to the register here. There's a dedicated register here, symbol here. Click that. That at the you see that the generic register symbol. You just add. How can you write this? You just write generic register. So generic register. You'll find that. You see that? RES, generic register device. That's double click, you get it generic because we are using this generic value. So that's done for this half wave rectifier. So let me start with the V sign. Click there on and click here. Let me make a zoom so you can understand. I think that now it's quite very big for you to see. So V sign is there. We added V sign. Then we'll add a diode. Okay, because we're building a half wave rectifier. In the half wave rectifier, a diode, a sine wave voltage, input voltage, and finally the resistance, the output resistance. Okay, we got the output resistance, and finally we just rotate clockwise to get it, and we got it. Now we will connect together. Okay, connect together. We will connect from one side to another side. Okay, we connected. My student, we connected already. So next, what we needed, we need a ground for this output. Okay, so go to the terminal mode, find the ground, and place that ground here. Okay, place that ground here. So connected it. It's done. We finally, okay, the value of resistance is given a 10K. Let's make it 1K. Not a big deal. A small resistance. Let's make it 1K. And what is the value of sine wave? The amplitude, because we all know that the let's make the amplitude 20 volt, and the frequency, let's make it 50 hertz. So you change these two values, and finally it is done. The circuit we are trying to build, the half wave circuit, that is done. Now we want to see the output graph, the half wave output graph. So we'll go to this instrument level, just after this probe, this instrument level, and go to the oscilloscope. We take our oscilloscope here, and we place oscilloscope here. We want to find out the output voltage. Okay, we connected the output R1 to the channel oscilloscope A. So it is done. Okay, is there any problem? Please please give a shout out to, or give me.
How about, sir, how about the other terminals, sir, like B, C, and D?
Hey, it's quite easy. No, you just connect B, C, no D, no problem. There are four
One by
channels.
one.
4 channels means that you
Yes.
can see 4.
You can choose.
Yes, you can see 4 graphs together.
Yes, sir. Okay.
Okay.
Understood. Yes, sir.
Okay. After connecting these two 4, then we will just go to the run the simulation button. The most left corner, the lower corner, left corner, we just run the simulation button, and we find a graph. Here you see that we have connected in the A, so we will whatever we will do in the channel A. There are 4 channels available here, so every 4 is, everything is similar. If you know the one channel, everything is similar. So first of all, make it DC, because the output is DC. Remember, the output we are getting, that is DC. So we made it DC. We can change the position from this here. We can change the duration position from here, the amplitude. We can change the amplitude here in terms of scale, that millivolt. And here we can change the duration. Okay, here we can change the duration. My students, what is it? It is the output or input?
It's input, output, sir.
Output. How can we understand this is output, my student?
Because
Sir, there's no positive.
Because
there's no negative, sir. Negative.
Negative sign. Okay, it will help us much more if we see the input and output together. Okay, let me connect the input voltage in the B channel, and let me run the signal one more time. You see that that channel B is connected together.
Yes.
So if we see that this is the input, my student, this is the output.
Outputs.
Okay. So in the input, you can see that during the positive cycle, we get the output positive, but during the negative cycle, we are getting 0. Am I clear here?
Yes, sir. Clear.
Okay. Let me plot together. Plot together means making it together, so it will help. You see that? You see only the yellow line in the positive
cycle, sir.
But in the negative cycle, your output
is a blue
totally,
line.
Yes, totally 0. Okay, so that is the my student. That was the half wave rectifier circuit. So let me take a picture for this so that you better see in the next time, or for finally. Let me take a picture of this. I'm gonna take a picture. Okay, let me screenshot this for your finally your understandable. Okay, let me take a picture, and I will share this picture to your messenger group later. Let me save it 1. So 1 is already there. Okay, 1, 2. Okay, this is done. Pardon me. So this is the circuit of the half-wave rectifier, my students. So let me take one more picture for this half-wave rectifier circuit. Please, everyone, give your role in the chat box, so I can identify that who's are present in this class. Okay, this is the half-wave rectifier circuit, and let me write 1, 3. Okay, after this class, I will show you for your understanding. Okay, so is it clear half-wave rectifier, or should I discuss more, my student? My student, is it clear?
Yes, sir.
We can move to a full wave rectifier. Can we move to full wave rectifier?
Yes, sir. Yes, sir. Go ahead, sir.
Okay. 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 Let me first of all let me remove everything for the full wave rectifier and build from the very beginning. Okay. For a full wave rectifier, if you remember, if we go to circuit, you see that there are 4 diodes. There are 4 diodes. The first diode will be the upside, the second diode will be the lower side, and third diode will be the lower side, and the fourth diode will be the lower side. So we have to, you know, connect those 4 diodes in the same way. And in middle, there is the resistance. And the output resistance is in middle. And the input voltage is the 2 terminal of the 4 diodes. So that's how. So we need 4 diodes. We need output resistance. We need a sine wave. So everything is available in our software right now. So we can make, first of all, we will try to build the diode bridge. Okay, so this is the first diode. Suppose then I take the second diode, then I take the fourth diode, and finally the fifth, the third diode, and finally the fourth diode. Okay, so the first diode will be my student, the upper side. So I make the rotate anti-clockwise. The second diode will be the lower side, so make it clockwise. The third diode will be the lower side, make it clockwise. And the fourth diode will be the upper side, so make it anti-clockwise. If you are still confused as to what is going on here, please try to see one more time. You see that this is upper side, this is lower side, this is lower side, and this is upper side. So in these configurations, for positive cycle, this D2 and D3 works. For negative cycle, this D1 and D4 works. So that's why in the both positive and negative cycle, we get the voltage, output voltage in the output for the full wave rectifier circuit. But in the half wave rectifier, there is only one diode. So that's why during negative cycle, we all know that the negative cycle, the voltage connects in the negative for a reverse bias condition diode. So that's why we do not get the negative voltage. Okay, so now let's go back to the software again. That okay, let's go back to the software again. So we have connected something like that. So we'll just now interconnect together the four diodes. Okay, connect all the diodes together and make a bridge. This is also known as Western bridge. To make a bridge. Okay, we connected. We connected. So the next task is the sine wave. That means the input voltage.
Inside of them,
Yes, please tell. Please.
inside of them there is a resistor, right? Am I right?
Sorry?
Inside of that for diodes there is a resistor.
Yes, yes. We will add. First of all, that is a bridge. Now we're giving the input voltage. Okay.
Okay, sir.
So let me connect this terminal to that top side, and let me connect this terminal to the this side. Okay. So our input is done. Now that we are coming to the output section. So the output is definitely a resistor, my student, to go input in the inside. Let me plot the resistance in the here. It's not a big problem. Let me rotate the clockwise. So basically, what will be that? This is the input. So the first section. So we'll connect the resistance in this side, and the other part will be Is there any change, my students, or it's still same?
Sir,
That,
it looks like different, but maybe it's same.
no, it's
Because
same because
yes,
you know,
okay. Because you know you connected. Yes, 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 sir.
yes,
Right, right,
it's
right.
same. It's same. Both the
Connected
terminal
the left. Yes.
are same. Just for the better purpose.
Mhm.
So we have the input, we have our output. It is not completed yet because to find out the voltage, we need a reference. So that's why we need to connect the ground. Okay. So we connect the ground
Yeah.
in the output section. Here.
Clear.
And let me edit the sine wave value. So we suppose it is 10 volts. Suppose for example 10 volt amplitude, and the frequency is of 50 hertz. So now everything is done. So what we'll do, we will add an oscilloscope. We go to the instrument and collect an oscilloscope here on and find out the oscilloscope here. Okay. Now we need to see the output voltage. We connected that. If everything is finished, next we'll go to the run the simulation button. So you run the simulation button. What is this, my student?
Yeah, this is the output, sir.
This is the output. If you see that, this is
This start.
the
Yes. Output.
output of full wave rectifier.
Rectifier.
Here, where we're getting both the input and the output.
Output.
Yes. Am I clear?
Yes, sir. Clear. Very clear.
So that's how we can make a full wave rectifier. Let me take a single uh, screenshot for your better understanding for next time. So let me clear. My students in physically, it will definitely require much more time. But when we are using software, it is not great in taking so much time. So please, for that, you know, talking about the same thing again and again, it's kind of boring thing. So I'm not repeating. But if you face any difficulties, sir, please try to discuss that one more time. Then I will discuss. No problem. But please ask me the questions. So please discuss that. Then I will not hesitate to ask or discuss. So please share your. Let me take the picture of this for your future practice if you practice in home. So suppose this one. Now next I will show an interesting thing. Next that we have already built this. We have already built this, my student. The bridge, the diode bridge we already built. There are 11 students right now available here, but I'm afraid that all I have given are the roles. Please, everybody give your roles in the chat box. All. I will make the chat role count at the end. Okay, so what can will be the next? Next will be that suppose here we have built the bridge, diode bridge. Interestingly, in the software there is a diode, the bridge is available. How to find out that? Go to the component mode, go to the P, that means peak device, and write bridge. BRIDGE, bridge. Write bridge. You will see the generic bridge rectifier. You double click that and make it OK, and click that bridge, and finally put here. You see that whatever we have made just manually, you can easily see that, my student, that it is already made here. So we can also make something like that. We just connect these input in the section and connect that in here, and this part with the resistance, and this part with the other side of the resistance. Okay, let me. Okay. You see that everything is same. Everything is same. We have connected together. But let's run one more time. The same output graph like previous. Okay. So there is no change. No change. So in this way also we can make a full wave. We can check a full wave rectifier or full wave bridge rectifier. Okay. So this was just an insight thing that I needed to share, that you can either build by using 4 diodes. There is a building bridge rectifier available in the in the Proteus, so you can also use that. So let me take a picture for this for your future. I will give all the pictures after finishing this class. Okay. Let me write 1 6. Okay, so should I move forward, or I need to discuss more about this full rectifier, my student? Please give your feedback. Is it okay, my student?
Yes, sir.
Can I move forward?
Okay, sir.
Yes, sir. You can move. But I don't know others.
Okay. Are you understanding?
Hello, students.
Are you understanding?
Yes, sir.
Okay. Now, now we will show the Zener diode, and now next we will discuss an important factor of Zener diode. Let me first of all go to the pick device and find a Zener diode. So write Zener. You see that interestingly, my student, in the Zener diode, there is one fixed Zener diode. We told you that the Zener diode is that particular diode that limits the voltage in the output section. Suppose I want to fix the output at 10 volts. At that time, you will use the 10 volt Zener diode. Next, suppose I need to fix the Zener diode at the output at 8 volt or 5.5 volt or 5.1 volt. So you will use that. So while choosing the Zener diode, there are 2 important factors that should be mentioned. One is, what is the Zener voltage? Because the Zener voltage means after that voltage, the Zener diode will enter the Zener region. And we all know that the Zener diode works in the, that is Zener diode, the Zener operation works in the reverse bias condition. And in the forward bias, the diode looks the same as the the normal diode. Okay. So one is the Zener voltage, another one is the current, the maximum current that diode, pardon me, the maximum current that diode can withstand or flow or allow to flow. Because if it cross, and practically if you cross that current level, the diode will be destroyed internally. You will not understand probably, but it will be destroyed internally. It will not act properly. So for that, you see that there are different types of Zener diode available. Different 4.7 for 53 milliampere. That means the maximum current across this Zener diode can flow, that is 53 milliampere. 5.1, 5.1 milliampere, 5.6. No, there are different values. So let's take 5.1, 49 milliampere Zener diode. So it means that the Zener voltage, after if you give the reverse saturation voltage 5.1, then it will enter the Zener region, and the maximum current will be the 49 milliampere it can withstand. Okay. So first of all, let's see how the Zener diode operates. So we all know that the Zener diodes will operate in the reverse bias situation. So let's rotate it 180 degree and apply a DC voltage. So we go to the generator mode. We apply a DC voltage, and let's see what is the Zener diode curve. And finally, we need resistance probably. Yeah. We need a resistance to show the output. So rotate clockwise and connect the resistance. Finally, this one, and nonetheless, there is ground. We need to connect the resistance ground. Okay, let me connect with the resistance with the ground. Okay, that's it. Now we'll not finished. We need to give, suppose because we want to show the Zener diode operation. So that's why there will be no fixed voltage. We'll give a range of voltage to see that when how it operates. So we make value X in the manual edits. We go to the something like the first example, value X, and we need to see the current of this Zener across. So let me go to the probe mode. We select the current probe and we fix. We make the current probe. Okay. So this is the current probe. That means that this probe will calculate the current of this. So let me write this IZ. Okay. IZ. Now we want to see, my student, we want to see that what is the current condition of this Zener diode. So we'll go to the graph mode. Similarly, the DC sweep graph. In the first example, we show how to do that and drag and make a DC sweep graph. We get it. Next, we'll go to the right click, go to the add trace. We need to add that probe IZ, add that. And finally, we need to edit the graph because let me stop value here is given 1 volt. Let me make it 20 volt. That we want to see 20 volts. Not 20, suppose 10 volt. Okay, 10 volt will be enough. Why I'm discussing it. After that, resimulate.
What the fuck?
One more time. Let me make the let me make it 20. So can you see this? You see this?
Yes, sir.
This Zener diode voltage, Zener voltage was 5.1 or probably 5
Yes, sir.
volts. So you see that we are applying a reverse voltage, isn't it? Because this Zener
Yes.
diode is connected with the reverse bias condition. So
Yes, sir.
we all know that in the reverse bias, there will be no current. There will be hardly any current. But when it will reach that Zener voltage, the current, huge amount of current starts to flow, isn't it? You see that? You see that my student, not huge, that when current starts to flow. You see that my student, here, what is this? Let me make it a zoom. Let me make it a zoom, so discuss this. You see that when from here, let me take the annotation so that it will help you. You see that when it reaches this is probably 5.1 or 5. When it reaches this, then the current starts to flow, though it is in the reverse saturation or reverse bias condition in the Zener diode. So that when it crosses the Zener voltage, at that time, my student, the current starts to flow in the Zener diode. So from this graph, we can say that, or we can also understand that in the before 0 to 5, there is no current. There is almost zero current. That is the reverse saturation. In the reverse saturation diode, we all know that the current looks like this, isn't it? This is almost the inverse. This is the alter, the inverted graph. So this is the Zener voltage. So when it crosses, then the current starts to flow. You see that this is the Zener region. So when it reaches that region, after that the current starts to rise. So that's how the Zener diode basically works. I think that you understand. My students, let me clear these and take a picture for your future reference. Next, we will discuss one more thing that how Zener Diode is basically used in terms of output parameters. I believe that my students, you are getting the electronics properly because in the next semester you will see some of the more advanced electronics. Okay, but at that time, this type of information, this type of understanding will definitely help you. And I believe that my students will do better in that course also because I tried to make a proper base for all of you. Let me take together pictures. I'm just taking this picture for you so that you see, next time when you practice. Are you feeling boring, my students?
Sir, it is exciting lesson, sir, because of you can see something clearly.
Yes. The main purpose is that whatever we read in the theoretically,
We
now
took
we
a
can.
theory as a theory, yes, sir.
Yes, we are comparing
By
with the theory.
sight.
Yes, we're comparing with the theory, and we are finally getting the result. So that makes our understanding much more clear. Thank you so much.
Yes, absolutely, sir.
Okay, let me remove everything and start that how the Zener Diode basically works. So my student, let me start with a example of us that how to find out the Zener Diode operation. So before that, we need a DC battery. So write a battery, BATTERY battery. The DC voltage source. Suppose the DC voltage source, we write it DC voltage source, the battery. So we take the battery. We take the battery. We put the value 12 here. Okay, no problem. And we take two resistance. Suppose this is one resistance, another one is here resistance. So I show you that one thing. Interestingly, suppose make it a clockwise rotate and connect together. Oh. Can you tell me, suppose it is not R2, it is RL, the load resistor. Load resistor, this is the normal R. Normal R, okay. So can you tell me what is the voltage across the RL? Anyone?
VL, sir.
Yeah, that is VL. What will be the value? The input voltage is V2 12. What will be the voltage across RL? Can anyone tell?
Yes, sir. It should be the rest of the voltage because that resistor 10k ohm, the normal resistor, will be drop a voltage. So that drop voltage, and you you subtract from the source battery,
Yeah. You're
then the
you're
rest of the
telling
value
about.
should be
Yes, I
VL.
know that. So telling about the process. But interestingly, you always need to remember that we all know that the input voltage will be divided into these two resistors, isn't it?
Yes, sir.
And
You can
it is
apply VD.
interestingly, yes, the voltage divider rule,
Yes, VD. Yeah, VDR.
the VDR, the voltage divider rule. But interestingly, you see that both the resistance value is same, isn't it?
Same. Yes, sir. Yes,
So
sir.
at that time, the input voltage will be divided equally. That's
Exactly.
the point I wanted to listen. That when the resistance of the two resistors are equal, at that time the input
Yes.
voltage will be divided equally. So
Yes.
basically, the RL voltage equals to 6 volts.
Exactly. Yes, sir.
So we can easily tell from without any calculation.
Yeah. Am I right, sir, or wrong?
Yeah, you are absolutely right. You are telling about the proper process, but I just wanted to listen that we can easily tell that the voltage is
Okay.
6 volt. But
Okay, sir.
now I want to make my students, I want to make the output voltage 5 without changing the resistance. Yeah, is it possible? No, absolutely not. If you change the resistance value, okay, if you change the resistance value, suppose if you increase this resistance value, at that time the voltage will be, be bigger here and be 7 volt here, 6 volt at the RL. But what is the Zener diode? The Zener diode gives us the opportunity to make without changing, just putting the Zener diode at the output. Am I clear? You see that
Yes, sir.
for better understanding, let me connect the some of the instrument. Suppose the DC voltmeter, so which will help us. Suppose a voltmeter here, that will help us to connect in the see the voltage across these, and also a voltmeter, one more voltmeter here to see the voltage of the resistance output voltage. I am just in these simulations, I'm just showing you that how the generator basically works and what are the purpose. You see that now let me run. Mm. What is the voltage, my
Yes.
students? Can you see?
Sir,
6
it is
volt
half
and
of.
It is half. It is basically 6 volt,
divided. Yes.
isn't it, my student?
Yes, sir.
So now what I will do, I will introduce a Zener diode that is 5.1 volt that will make fix the output voltage. Let's see how. Suppose this Zener diode I am placing here. Okay, that simulation is going on. So this Zener diode is placing here. Okay, and so let me rotate anti-clockwise because we need to make Zener diode in reverse or forwards. Reverse.
Yes.
So we need to connect in the reverse, bias condition.
The value should be changed.
Okay. Now output is across the Zener diode. We just nothing changed. We just place a Zener diode in the output, isn't it?
Yes, sir.
Isn't it? Okay. Let's see the difference. Just click the simulation. Let's see the voltage. What is the voltage?
Oh, sir. Load voltage will be decreased.
Yes, because we wanted to decrease because we wanted the load voltage about 5 volt, isn't it? We
Yes,
didn't
sir.
change anything.
Yes, sir. We add only Zener.
We didn't
Zener
change
diode.
anything. We just place a 5 volt Zener diode in the output, and our output voltage is, decreased.
Sir. Yes.
Though
Yes.
the voltage divider rule, you see that here is 4.96 volt. That is a different cause. That is known as RD effect. Sometimes a Zener will not, wait for exact 5.1 volt exact height because the curve is. Let me discuss this one first because it will confuse you because for the forward bias it is not something like that. This sharp, not sharp. You see that the curve will something like this, isn't it?
Yes. Yes,
So
sir.
because it is known as early effect. So a little bit earlier the operation starts. That's why you see a little less voltage, but almost close to 5 volts. Okay, that was the thing. So interestingly that we just nothing changed. We just changed. We just placed a Zener diode in the across the resistance. But according to the voltage divider rule, the voltage should be 6 volt.
Yeah.
But if I wanted to change the circuitry, and it will be difficult because if I wanted to change this resistance value at that time, it will be the output voltage can be changed according to the voltage divider rule. But we can limit the voltage easily by using a Zener diode. So that is the purpose of Zener diode. Is it clear now?
Yes, sir. It's clear.
Yes, sir.
It's absolutely clear. Okay. Let me find out that next thing is that that how important the let me there is some noise coming on, so mute because some noise. So interesting to see that now next that how much important the amount of current will flow across the Zener diode. That is very much important. So next I will show you that the importance of the current. So let me remove everything. Okay, before removing, let me take a picture. Let me take a picture for your future reference. Then we'll discuss that, the importance of current rating, because before starting we say that the Zener diode has two parameters. One is the Zener voltage and one is the maximum current, the IZM. That means the maximum current that is allowed across the Zener diode. Okay, so that is the important factor. So you can also take that. You can also take that. Let me save that, and after that we will okay, got it. Okay, let me remove everything for your. Okay, oh my God, it was in the simulation. That's why it is not removed. Now it will be removed. Okay. Next, we will now. Okay. It starts with the battery source one more time. Okay, battery source. Then we will use two resistance. Suppose one resistance here. We want to see now all the currents, all the voltage of the circuit. So that's why we will add ammeter. We all know that the ammeter should be connected in the series. Okay, not in the parallel. So we want to see the current across this. So we introduced an ammeter here. Okay, now we want to see the voltage of this. So we introduced a voltmeter here, suppose. Uh, Sorry, my PC is very slow. So we introduced a voltmeter here. Okay, so this voltmeter will give us the voltage of this R1. Okay, and this ammeter will give us the current of this circuit. So let me connect. Let me connect one more resistor. So resistor, this is the load resistor. Let me make it rotate clockwise, and let me connect here. Okay, and so I want to see the current across this resistance, and let me connect Zener diode here. Okay, let me connect the Zener diode here. Rotate anti-clockwise. Okay, where I'm connecting the Zener diode here. I wanted to see the current across these two branch also. So I need two DC ammeter. I wanted to connect two ammeter here. I want one more ammeter here to just see the volt current across this branch. So my student, now I will connect this other terminal of the voltage and complete the circuit. Suppose here, okay, this it is completed. Okay, one thing is left. That is, I wanted to see the voltage of R2. So if I wanted to see the voltage of R2, so let me connect. I'm just connecting the voltmeter and the ammeter just for the purpose, just for the seeing purpose. Suppose I'm connecting the voltmeter across it. Now, my student, let me give a voltage of suppose 8 volts. 8 volts here. Let me find out. Okay, the current will flow not in ampere. It will flow in the milliampere. So we need to make it milliamperes, because ampere is very big ampere. At that time it will not show. So we need to change that ampere to milliampere also. And whatever I'm doing, it is also recording. So you don't need to worry about that. You see that, you check, and okay. Now it is given here. So let me play this opening. So the simulation, please give it time. My this is very slow. You see that, my students? Can you see the voltage?
Yes, sir.
See that their input voltage is 8 volt, and there are two resistance. One is R1, one is R2.
Yes, sir.
Let me make R2 RL. That will help us for understanding.
Better understanding.
Yes. And this R for R. Okay. Sorry, this class is very big or long, but for understanding or for study purpose, we need to sacrifice this.
Yes, sir.
Okay. Okay, you
Sir,
see. Yes, please
Yeah,
tell.
the voltage are divided. Yes, sir.
Yes, divided, absolutely divided and equally
Yeah.
divided. Why?
Equal divided.
Because both the resistance are equal, 10 kilo ohm. Okay.
Yes, sir.
So, but my students, the point is to think that you see that there is no current flowing in the
Zener Diode.
Zener
Sir.
diode,
Yes,
Yes.
isn't
sir.
it?
Yes,
Isn't
What,
sir.
it?
sir? Yes.
Why? Can you even describe why?
Yeah, because
I asked you, sir.
Oh, you asked me. Yeah, I will. I will
Yes.
definitely answer. But if anyone,
it become question to question.
yes, it become question to question. Okay, let me answer you. You see that my student, the Zener diode is not on. Why? Because the voltage
It's a
across this
4
Zener
plus.
diode is only 4, and the Zener voltage is 5.1. So it will never, it is in the reverse bias conditions. It will never, it is open. Here right now it is open circuit. Let me
Yes.
check.
Yes, sir. There's no voltage.
Okay, okay.
Yes,
Drop is there. If
this
there's no
is
voltage, there's no current.
yes, this is in the open circuit. Because that's why. Because why? Because there is only 4 volt. When this voltage will go 5, at that time the small amount of current will starts to flow. Because at that time the Zener diode will enter the Zener region. Am I clear?
Yes,
So
sir.
okay, let me let
Very
me
clear.
let me make so what we'll do, okay, so now the interesting thing is that our task will be that find out the voltage range, the voltage range at that the Zener diode will be on safely. What is the current maximum current rating? 49 milliampere. Remember, 49 milliampere is the maximum current that this
Yes,
Zener
sir.
diode
It's not that
can
has.
flow without any problem. So we need to find out the voltage range at which the Zener diode will be on, definitely on, but also it will be on properly without damage. So there should be a minimum range, there should be a maximum range, isn't it? If you
Yes.
remember, we have also solved this type of mathematics in our classes. So there should be a minimum range, there should be a maximum range. So what is the minimum range? The minimum range will be always uh, at that value, so that the Zener diode gets the 5.1 volt at least. So let me make okay, first of all
Or
let me make it 10. Let me make it 10, and let's see what happens.
yes. Some,
You see that?
some
Okay.
current increasing, sir.
Yes, yes.
Even the Zener diode got the ampere, milliampere.
A small amount. That means that he just entered the Zener region. He just
Okay.
entered the Zener region.
But
So
still, it hasn't reached, sir.
yes, suppose okay, make it
12 minutes.
not 12. Let me make it a little bit later, less. Suppose 9.5 or 9.6.
Yes,
Just
okay.
just 9.6, and go to the
Simulation.
It's still, sir, still.
no. There is no
No, no, no.
current, isn't it?
There is no current.
There
Exactly.
is
Yes,
no
sir.
Still
current.
no current.
No current. It's at 0. Let's make it
8 or 9, sir.
9.8 or 9. Okay, 9.9. Let's make it 9.9. So
Oh, number one,
probably
sir.
now we'll get the voltage. Yeah,
Yes.
just that
1,
means
yes.
Okay, okay. We got
that
the
means the starting minimum voltage that would require to enter the Zener region, that is 9.9, isn't it?
yes, sir.
Okay,
Sir.
now this is the lowest. Now we need to find out the highest value without changing any component. Without changing, we are not changing the resistance value. The resistance are fixed. So
Only
suppose
the battery, sir.
yes,
Battery can change it.
yeah, we will change the, because we need to find out the maximum range
Yes.
in the battery. Remember the current across this Zener diode. What is the maximum range? You remember 49
49,
milliampere.
sir. Yes,
Yes.
49 milliamps.
So the current cannot exceed the 49. Okay, let me make it. Let me rise the voltage level. Let me make it 20. Let me make it 20. The lower range is 9.9, my students. Remember, I make it 20. Oh my God,
Oh,
huge amount of
One, sir.
current.
Yes,
Like
yes.
what is one? No, it is 1 milliampere. My student, it is only 1 milliampere.
1 milliampere. Sir. I said 1.00 milliampere.
I thought that it is 1 ampere. Okay, it is one milliampere. So we can go forward, no problem. It is okay. 20 is also okay for this Zener diode. Okay, make it 40. Okay, or let's make it 30. 30 volts. Let's make it That is 1.9
Still
milliampere
2,
only.
sir, or 1.9.
Here to
Okay.
2, sir.
Okay. Let me make much more bigger one. So suppose make it 100.
okay.
And
Yes, let me make it 100 because we have chosen the resistance value wrong. We choose
Yes, sir.
bigger value. So make it. You see that what is the value here?
still 8.9, sir.
8.9. So this Zener diode can
It
withstand
should be 9.
100 volt. Also, it can withstand more. Let me change. The what was the minimum voltage? 9.9. Remember. Suppose make it now 500. 500 volt.
V. Yes.
Yes. You see that 89.9. 89.9.
Yes, sir.
And interestingly, you see that, my students, the output is fixed for around 5. But whatever the voltage that is dissipated, that is across these resistors. So that we are increasing the voltage, but in the output, is it changing?
No, sir.
Sir, no.
It is why? Because there is a Zener diode available here, isn't it?
Exactly.
Yes.
Yes.
Yes, sir.
So you see that here is 500. So let's make it 501 or 2. That will, because that will, suppose 500, 505.
49, sir.
Yeah, we wanted to make it 49.
So much.
It crossed.
Oh,
It crossed.
49. Yes, cross, sir.
So that means
Maybe
505.
5 and 504 or 3, sir.
Yeah, 504. So that is the maximum value of the voltage that can be applied Zener diode without any problem. Okay, is it clear to you?
Yes.
I think
Yes,
it's
sir.
absolutely clear to you. But interestingly, you see that we are increasing so much voltage here, but interestingly, the output voltage is not changing at all because there is a Zener diode. So that is the purpose of Zener diode, to make fixed
Output
the
voltage.
output voltage. You
Voltage.
just take a particular voltage, Zener diode, your output will be fixed. So now what we'll see, we will just remove this. We remove this. Now see the difference. My goodness. You see that the output we are getting 252
252,
volts,
sir.
252 voltage. But when we apply the Zener diode, we saw that the output was fixed, exact that voltage. Is it clear, my students? Now, I think that
Yes,
after
sir. Yes, sir.
it is
Absolutely.
Yes, sir. It's clear.
absolutely clear what is the purpose of the
Clear.
Zener diode. So that's it for myself. Let me take that picture one more time. Yes, take that. You practice by yourself in the home. So I tried my best to make you the clear Zener diode operations. So now that you can know that what is the actual meaning of the Zener diode, or what is the actual function of the Zener diode, to make voltage limiter or the voltage regulator in the output. So that is the main purpose of a Zener diode. So that's it for today, my student. I tried my best. Is there any questions for regarding from you? You can definitely ask me. But if you don't have, then it's also okay. I'm glad you don't have. Probably everyone understood. Probably. So let me write the role, and in between, is there any questions? You can definitely ask me. I'll be more than happy to answer all of you. Is there any question, my student?
No, sir.
Sir, that's exciting, sir.
Okay. Roll batch 30, roll 14, batch 30, roll 4, batch 29, roll 21, batch 30, roll 13, batch 29, roll 16, batch 30, roll 2, batch 30, roll 3, batch 29, roll 7, batch 29, roll 1, batch 29, roll 15, batch 30, roll 4, 30, roll 4, batch 29, roll 4, batch 30, roll 6, batch 29, roll 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh my God, 14 students. How can it be possible? Okay, probably there's some.
Two students are,
Students are right.
yes, sir, two times, sir. They have written
Yes,
their
yes,
roll number two times.
yes.
Yeah.
This is one is roll 34 and
Rule 1 and rule 7, sir.
yes, roll 1. Yes, I got it. Probably 12 students, not 14 students. 12 students. Okay, that's it for today, my student. I have enjoyed while staying together because the laboratory class should be physically, but I tried our best to make it as interactive as possible. So if you face still any problem, please don't hesitate to reach me. I'm always here. See you in the next class. What do you say?
Thank you, sir.
See you in the next class. I'm